Howdy folks, Sharpie Point here. Today I want to talk to you about the different materials that are in Oxygen Not Included and how to best to use those materials in which to build, such as pipes, ventilation, or machinery. Here we have obsidian, igneous rock, granite, sedimentary rock, sandstone, abyssalite, wolframite, tungsten, copper ore, copper, gold amalgam, gold, iron ore, and iron. Some of the materials require metal refinery in order to get tungsten, copper, gold, and iron. Here I have just a simple experiment showing you the difference in how the materials affect areas. Here I have two liquids. I have a cold crude oil at minus 30 degrees. I have petroleum at 254.9 degrees Fahrenheit. So if you go to the temperature overlay, you can see that these two materials, two liquids, are not transferring the heat from one space to another. Alright, so let's look at each of the materials in more detail. Obsidian. Now obsidian has two specific things that we're going to look at. One is specific heat and thermal conductivity. Specific heat is the amount of heat required in which to change the unit's mass of the substance by 1 degree in temperature. Thermal conductivity is the property of the material in which to conduct heat. The higher the thermal conductivity, the better the heat transfer. The higher the specific heat, the more heat is required in which to change the temperature by 1 degree. So obsidian has a specific heat of 0.2 and a thermal conductivity of 2. Igneous rock, 0.2 and thermal conductivity of 2. Granite, 0.79 specific heat, thermal conductivity of 3.39. Sedimentary rock, specific heat 0.2, thermal conductivity of 2. Sandstone, specific heat of 0.8, thermal conductivity of 2.9. Abyssalite, specific heat is 4, thermal conductivity 1e minus 0.5. Wolframite, specific heat 0.134, thermal conductivity of 15. Tungsten, 0.134 specific heat, thermal conductivity of 60. Copper ore, specific heat of 0.386, thermal conductivity 4.5. Copper, specific heat of 0.3885, thermal conductivity of 60. Gold amalgam, specific heat of 0.15, thermal conductivity of 2. Gold, specific heat of 0.129, thermal conductivity of 60. Iron, specific heat of 0.449, thermal conductivity of 4. Iron again, specific heat of 0.449, thermal conductivity of 55. So now that we know what each material, as far as its specific heat and thermal conductivity is, that'll let us better decide on which to and how to construct our base, and using the proper materials in its proper location. For instance, if you're transferring liquids, you want to use the best material that has the least amount of thermal conductivity. which is going to be your abyssalite. If you're transferring gases, again, abyssalite's the best material. Now, you can use what's called each of the materials in locations that you don't really care about, so you don't just have to specifically rely on abyssalite in which to construct all your liquid piping or ventilation piping. If you're not too concerned about the difference in the surrounding area as far as the heat concerned, by all means, use other materials. But here I'm going to show you actually what each material does as far as it related to the surrounding areas. Each of the piping corresponds with the material that's listed below. For instance, this liquid pipe is made from obsidian, igneous rock here. And also have the same thing for insulated pipes. So let's take a look at what happens when you pump hot liquid through each of these pipes and what the difference is between standard piping versus insulated piping. So with that, we'll go to our temperature overlay and we'll turn on our pumps. First, we're going to use these pipes that are standard pipes. So let's turn on our pump. Well, if we can get it to work, there we go. Alright. Now, as you notice, the hot liquid is coming through. The pipes themselves have heated up. And once they start heating up, now they're going to start heating up the surrounding area. The higher the thermal conductivity, the faster the area around it is heated up. From here to here. These have a really high thermal conductivity, so the area is getting heated up a lot faster. So, now that we've seen regular pipes, let's see the difference in insulated pipes. But if you also notice that there's one section here that's actually still staying green, and that's because the pipe is made out of abyssalite. Even though it's made from just standard piping, there is no heat loss or heat gained because of the abyssalite. So let's go ahead and reset our experiment. Turn our pump back off. Now we have our experiment reset, we can go ahead and use the insulated pipes. So now we're going to turn our pump back on. Now the insulated pipes will slowly heat up, but once they do heat up, they'll still heat up the surrounding area. So once again, the difference between the standard pipe and insulated pipe is the insulated pipe requires more material in which to construct. But as you can see, the pipe is still heating up, even though it is made out of insulated pipes. The only thing it does, again, doesn't change is the abyssalite. The abyssalite doesn't conduct any heat. So it's a very, very good insulation. Whereas the other materials, not so much. So that gives you a visual explanation on how to use the different materials in which to construct whatever you're trying to build. So let's go ahead and turn our pump back off. Now, there's something else I was wanting to show you is on the actual machinery itself. So let's get out of our temperature overlay. We have 4 gas pumps that are here. This one here is made from copper ore. This one, wolframite. This one, gold amalgam. And this one is from iron ore. Now, the main things you want to look at when you're conducting your machinery is if that piece of equipment is going to be setting in a hot zone, a cold zone, or a neutral zone. If it's going to be setting in a neutral zone, best materials you want to use would be iron or copper and possibly wolframite. However, if the piece of equipment is going to be setting in a much larger or much hotter environment, gold amalgam is going to be your best. So why is that? Gold amalgam adds an overheat temperature by 90 degrees. So, for instance, the copper has an overheat temperature of 167 degrees Fahrenheit. The gold has an overheat temperature of 257 degrees Fahrenheit. So, the gold pump will withstand a lot hotter temperatures versus the copper pump. Now, there are also a few things that you can also look at is flooring. If you're afraid that you're going to be having heat transferred from one area to another and want to insulate that area, use a Bisalite. If you're not too concerned about it, you can again use whatever material you have available. Other things you can look at are the decor. Some materials give a bonus decor. So for instance, if you're going to build a floor, you'll see that granite has a bonus decor of 20%. So does sandstone by 10%. So that adds to your decor of your base. So this is just some of the ways you can use your different materials and how to best use those materials, so that you can always wonder, well, why am my base is getting too hot, or why am I getting too cold, or why things are happening that you think or should have controlled but you don't. Each material, before you actually construct, take a look at it. See if it's the right material for the right job. And if you have any questions or comments, leave them down below. I'll be more than happy to answer them. Thank you for watching. Until next time, take care of yourselves and each other.